All right, so this is just a warm up on what we've done over the last 2 days in class, going over the two types of distributions that we've looked at, our probability and our binomial distributions. So if we look at number one, the following table is a valid probability distribution for a random variable x. So what must the probability of 1 be to complete the table? So to do this, we'd have to remember our requirements to be a probability distribution. So remember, the requirement is that all of these values would add up to 1. So if I know that my first couple values are 0.34, 0.17, and 0.28, right, and I need this to add up to 1, I would need the rest of this, probability 1 to be the rest of this. So 0.21 would be what has to go here so that those values meet the requirement by adding up to 1. So it would have to be 0.21. Okay, so then in our probability distribution, if I want to find the mean, remember we're going to do x times p of x and then add our values together. So I'm going to do 0 times 0.34, which is just 0. 1 times 0.21 is 0.21. 2 times 0.17 is 0.34, and 3 times 0.28 is 0.84. So then if I add up those values, 0.21 plus 0.34 plus 0.84, I end up with 1.39. So my mean is 1.39. Remember, you just multiply x times p of x, and you add those values together, and that gives us our mean. So for our standard deviation, it takes a little bit, there's a couple more steps to it. We're going to start by multiplying our x squared times p of x. So we'll square all of these values and then multiply them. So 0 squared is just 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. So I'm going to multiply 0 times 0.34 is still 0, 1 times 0.21 is still 0.21, 4 times 0.17 would give me 0.68, and 9 times 0.28 would give me 2.52. So I multiplied my x squared times p of x. I'm going to add these values up again. It's the same process, same start to the process here. So I get 3.41, but that is not my standard deviation. To find my standard deviation, I'm going to take the square root of that value minus the mean squared. So I take the square root of this value that I just found minus my mean squared. So if I do that, 3.41 minus 1.39 squared, I end up with 1.22 as my standard deviation. So just remember, for your standard deviation, there's a couple more steps than just adding up that x squared times p of x. So that was just a quick overview of our probability distribution. Last class, we started talking about our binomial probability distribution. So remember, that's when the outcomes are just success or failure. So to do our binomial distribution, we need 3 values. We need an n, a p, and an x. So we're actually going to find the probability of each of these x values given this n and p. So we'll go to second vars, and then we got to go down to letter A, which is our binom PDF. Our number of trials is n, so it's 4. Our probability is 0.6. And then we're going to start with the next value of 0. So when I do that, I got a probability of 0.0256. I'm just going to copy and paste this now and change this to 1, because now I just want to know it when x is 1. So I get 0.1536, and then I'll change it to 2, because I'm just trying to find it for each of these x values. Then I'll do it for 3, and then I'll do it for 4. And if I was to add these up, I would actually find that these, when I add them up, equal 1. So a binomial can also become a probability distribution, just depending on if you're looking at every single scenario. I'm looking at all values of n between 0 and 4. So What we really looked at last class is like scenarios where we're trying to find the probability of something taking place. So a fair coin is tossed 12 times. What is the probability of attaining exactly 10 heads? So if you think you tossed the coin 12 times, so your number of trials was 12, and then the probability of flipping a coin and landing on heads, right? Our probability of flipping a coin is always 0.5. And then I want to know that it happens exactly 10 times. So x would equal 10 in this case. So I'll go back to my calculator, hit second vars, go down to letter A, my binom PDF. My number of trials was 12, my probability 0.5, and I want it to happen exactly 10 times. So when I do that, I get 0.0161. So there's like a 1, if I want to turn that into percentage, a 1.6% chance that that would happen. All right, so then our next one says a fair coin is tossed 15 times. What's the probability of obtaining at least 13 heads? So again, n is 15. That's the total number of trials. I'm still flipping a coin, so my probability is still 0.5. Now I want at least 13. So that means I'm looking at 13, 14, and 15, because I got to go all the way to the n value of at least 15 or at least 13 of them. So I'm going to have to find each of these each of these 3 probabilities and then add them together. So I'll start with 13. So second vars, go to my binom PDF. I have 15, my probability is still 0.5, and now I want 13 this time. Okay, so then I'm just going to change this. The only thing that's going to change here is now I want to know 14. So if I just go up and highlight what I want and I hit enter, it will paste that below and then I can edit it before I hit enter again to compute. So I just found the probability of 13, 14, and 15. So now I want to add all of these up. Instead of writing them down and trying to carry decimals, just highlight it, hit enter. It'll paste it below and then hit plus. And then go to the next one, hit enter, plus, and the next one, hit enter. And that will tell us all 3 of those added together. So I get 0.0037 as my probability of getting at least 13 heads and flipping a coin 15 times. So that's just a review of what we did over the last 2 days before we move on to our next type of distribution.